Hi guys, welcome back to Colorado State University STEM videos. I'm Miss Stephanie and I'm here for part 2 of our shellless egg experiment. Now this experiment is all about osmosis. What is osmosis? Well, simply put, it's just the movement of water. Water moves from higher concentrations of water to lower concentrations until equilibrium is met. That just means there's equal water on both sides. Now usually this is through a membrane, kind of like our shellless egg, semi-permeable membrane that we learned about last experiment. Well, this week we're going to use that membrane to complete osmosis by testing a couple of different liquid substances to see which way water moves, into the egg or out of the egg, or maybe it doesn't move at all. We'll find out. So first of all though, make sure mom's okay with you grabbing some simple ingredients and come back with, of course, your shellless eggs. By now you should have 4 of them, right? And then you're also going to need your spoon again, more jars, 1 per egg, your tape and marker to label. Then if you have corn syrup, bring out your corn syrup. Ask mom where to find it. If you don't have corn syrup, you can use a solution of water and sugar. All you need to do is boil 1 cup of water and mix in half a cup of sugar slowly while it's boiling to dissolve it all together. That would be similar to your corn syrup solution, a little less thick, but you could use it and get some similar results that way. Make sure when you use a stove you have parental permission as well as them watching you, and definitely let the liquid cool before you use it for this experiment. Additionally, if you have it, pull out mom's kitchen scale. You're also going to want a small bowl, glass or plastic, doesn't matter, to hold your eggs when you're measuring. And if you don't have a kitchen scale, then you can pull back out your ribbon or string and your ruler and use those to collect your scientific measurements for this experiment. The only other ingredient you need is water. Pretty simple. All right, go get your ingredients. I'll be right here when you come back. All right, guys, so now that you've got everything that you need, let's start with those shellless eggs. Now remember, in order to complete part 1, you needed to take your egg out of the vinegar and measure its girth to see if it expanded, contracted, or stayed the same. Hopefully you've already done that, so we won't do that in this part of the experiment. Now I'm going to take my egg out of the vinegar very carefully, because remember, it's not protected by a shell anymore. It's just a membrane. So you want to be very gentle. You'll do this for each of your eggs. You should have 4, right? Take your egg out. There's your shellless egg. And what do you notice about it? Does it look smaller, bigger, or the same size? Here, let me show you a normal egg out of my refrigerator to kind of compare the difference. Now, place your egg down for a minute, and we need to calibrate your kitchen scale. Now, for your measurements, for your data today, you're going to want to make sure your scale is measuring in grams, and you're going to want to tare your scale, which simply means zero it out with your container on top. That way you don't count the container's weight as part of the egg weight. So while I get that set up, go ahead and get yours set up too. Remember, you're going to want to measure in grams. You're going to want to put your empty container on top, and you're going to want to tare or zero that out before you weigh your eggs. All right, mine zeroed out. So let's weigh our first egg. So just gently put it down on the scale. And I have 97 grams. That's a big egg. So I'm going to write 97 down. And just like we did the last time, go ahead and start making your label for this egg. Make sure to include its initial weight on there. So 97 grams. Now this egg I'm going to put in corn syrup. So I'm going to go ahead and write that on the label as well. And I'll put that label on one of my empty jars. All right, so now that I have my jar and my label, we're ready to add the shellless egg. Very carefully, it almost didn't fit. Now take my corn syrup, or if you make your sucrose sugar solution on the stove, you can add that now as well. And you're going to want to add enough to cover the egg all the way to the top. Now, I noticed when I did this experiment, my egg tended to float. So as long as you have enough in there to get the egg covered and it starts to float a little bit, you're good to go. All right, corn syrup and your shellless egg. So now you're going to want to put the lid on, and this experiment is going to take drastically less time than the last one, just about 8 to 12 hours. So if you do this at night, you'll see results in the morning. And that's all you have to do. Now for your other 3 eggs, I would suggest doing one in water, because that's what I did. And then you can do some other experiments. Maybe you want to do the orange juice from the first experiment. Maybe you want to just do vinegar. That's what I did for my control because they were already in vinegar. So my control, meaning the one I did nothing different to, was set in vinegar for this experiment. Once you decide what substances you want to put your eggs in, make sure you weigh them first, mark it on the label, and then set them each individually in different jars to see what happens. Now, what's the point again? Remember, we're experimenting with osmosis, so we want to see which way water travels. Now, in your water jar, that's going to be simple. There's a lot of water in there, so water could go one way or the other. How about in the corn syrup jar? Well, corn syrup in itself doesn't have a lot of water in it, but does your egg have water in it? Yeah. Eggs actually are about 75% water. So there's water in your experiment. We're just going to see which way it flows. All right. So once you get your 4 jars set up, make sure that you put them in a safe place and then just watch them and see what happens. I would suggest right now would be a good time to make your hypothesis. That means your best guess about which direction water is going to go in each jar. And then in 12 hours, we'll see who was right. All right, guys, so we've had enough time now pass. Pull out your jars and let's see what happened. So let me show you my 2 jars that I started, and now it's been 12 hours. I have a corn syrup jar. You guys see that? And I have a water jar. And then my control was a vinegar jar. So the control didn't change. Now, what do you notice about these 2 jars? Well, first of all, this jar has something floating in the top of it. That is actually the egg's membrane. See, what happened is water flowed into the egg because there was less water on the inside of the egg than there was in the water solution that was surrounding the egg. Therefore, the egg expanded and there was a weakness in the membrane that actually caused it to boop. So the membrane's actually floating on top, and then the egg and the egg sac and everything is on the bottom. Which way did water travel? Now in the corn syrup one, you don't see a floater, which is good, but I can tell you from my observations, that egg actually looks like it shrunk. Now, the water egg we can't measure because it exploded, but the corn syrup one we can. So on my label, this egg started at 71 grams of weight, if you can read that. So let's carefully take out the egg without puncturing the membrane. And you're going to want to wash it off because we don't want to weigh the corn syrup that's coming out with it. So gently wash it off. Try not to let the water hit the egg itself. Turn on your kitchen scale. Make sure you're measuring in grams and that your bowl is zeroed. Now we're just going to measure the egg itself. Well, guess what? How much did the egg start out at? 71 grams. We are down to 38 grams. Wow. So the egg lost a lot of weight. What does that mean? Which way did water travel? Well, that's osmosis for you. I'm excited to see what your eggs do. And make sure you leave me comments in the bottom to tell me if you had similar results. Did your water sac burst like mine? Did your cornstarch or corn syrup egg shrivel up like mine? And let me ask you another question. What do you think we could do to get this guy back up to shape? Anything? Think about it. Use osmosis. Now, if you didn't see experiment 1 and you don't have a week to make your shellless eggs, you want to see osmosis now, then here's another way you can do it. Have mom or dad pick up some gummy bears and take them home and do the exact same thing. Have a control, one you do nothing with, and then add your liquids. For this experiment, I again used water, and I used a sugar concentrate, just like I told you guys to make on the stove. So, gummy bear number 1, gummy bear number 2. Can you see it? Whoop! Gummy bear number 2 fell. And gummy bear number 3. If I can put them up next to each other and let you guys see them on a paper towel. You guys see that? Gummy bear number 1, closest to my finger, is our control. The yellow gummy bear is slightly bigger, which means he moved a little bit of water inside of him, but not much. And then my gummy bear number 3 expanded to almost double his normal size. This experiment only took about 4 hours, and I'm not going to tell you which substances did what to which gummy bears. I want you guys to figure that out. So, have fun experimenting with osmosis. Make sure that you label everything. Make your hypothesis. Which direction will water go? In or out? And have fun. Thanks for tuning in to this week's STEM Talk, and we'll be STEMing with you guys later. Bye.